So hi guys, so in this video I'm going to talk about equation of a parallel line. Then in the next one I'm going to talk about the equation of a perpendicular line. I have decided to actually break it down into two different videos because I don't want to like super huge videos. Let's talk about equation of a parallel line. Guys, here I'm not actually going into a lot of details about like the conceptual details about parallel and perpendicular lines. For that you can actually go back and refer to your textbooks, or you can research stuff online, and if you still need to know more about that, you can always like give me your feedback, comments, and I'll be happy to actually go over those concepts. But there's two key things that we need to know in order to write an equation of a parallel line. So I'm quickly going to talk about that, and we're actually then going to actually start solving examples, because my main goal with this channel is for you guys to be able to see solve examples step by step, and then use that information to help you do practice more exercises, more problems, and be successful. Okay, so the two key things about parallel lines, which you can already see right here, is that the parallel lines have the same slope, and the second key thing is that they do not intersect. So something that comes into my mind as soon as I think about parallel lines is like the railroads, right? So they are parallel, they do not cross each other. And then of course, if you think in terms of the slopes, they have the same slopes. Guys, you can actually like if you have a graphing paper, a grid paper, you can actually draw two lines, and then you can see like you can see whether they are parallel based on like their slopes. And of course you will see that they do not intersect if they keep on going forever. One other key thing that people sometimes kind of neglect when they think about the parallel lines is, in addition to like having same slopes, the y-intercepts are going to be always different for the parallel lines. So please make a note of that. The y-intercepts are always going to be different. So they have different y-intercepts. So I mean, this information is going to be useful when we try to actually write an equation of a line. So without wasting any further time, let us look at this example and we'll go over all the steps. So example 1 is that we want to write an equation of a line which is parallel. So I like to use these to represent parallel, which is parallel to a given equation, which is 4y minus x equals to 20. So this information is already provided to us, and which goes through, or which passes through the point 2, negative 3. So let's go back and revisit this example. We want to write an equation of a line which is parallel to this given line, and which passes through this particular point. So you can visualize this. So it's something like this. Let's say we have this x and y axis, and we have a line which is already given to us, and let's say this line looks like this. Guys, I'm not saying this is the exact representation for this line, but I'm just giving you an opportunity to kind of visualize this thing. So let's say if this line is represented by this line here on the graph, then we want to create a new line which is parallel to this line and passes through this point 2 and negative 3. So let's say this is 1, this is 2, and 1, 2, 3. So let's say it's this point, 2 and negative 3. So basically we want to create a line which is parallel to this line. Let us call this L1, line 1, and then which passes through this point. So roughly speaking, like it's going to look something like this. Okay, so let's call this line 2. So that's more like a visual representation of this line. Okay, but here we want to actually be able to write an equation of the line. Once we have the equation, we can actually, if we have a graphing paper, we can draw both the lines, and you will be able to see that they are parallel. Okay, so let's go ahead and start the solution method. So the key thing that we need in order to write an equation of a line is the slope, the y-intercept, or if we have a point, then we have a way to figure out the y-intercept, or we can use any of the two equations that we have learned in the previous videos to write an equation of a line. So when we look at this given piece of information, we have a point, which is good because we need a point to write an equation of a line. But the key thing that we need is the slope. And directly looking at this equation, we do not have the slope. But let us ask ourselves, is there a way to kind of identify or find slope from this equation? And if you think about it, there is a way. And to kind of figure out how to do that, let us go back and remind ourselves the slope-intercept form. Guys, the slope-intercept form looks like this: y equals to mx plus b, right? So if we have this equation in the slope-intercept form, y equals to mx plus b, then we should be easily able to identify the slope, because what is the slope? The slope, m, is the coefficient of x. So if we have this transform into this form, we should be able to find the slope. Once we have the slope, then from there we should be able to write the equation of the new line. So let's go ahead and actually do that. So what I'm going to do first is I'm going to rewrite this equation. And then if we want to transform this equation into a slope-intercept form, so guys, please look carefully at the slope-intercept form. What is unique about this slope-intercept form? The unique piece is that the y is by itself and everything else is on the right-hand side, correct? So can we accomplish that for this equation? Yes, we know how to use the basic algebraic manipulations to do that. So we want to get rid of everything else on the right-hand side and y by itself. So in order to do that, first we'll add x to both sides. Right, so it would be 4y equals to x plus 20. We are not going to combine these because they are not like terms, so we're just going to write x plus 20. And then in order to get rid of this 4, we're going to divide both sides by 4. So you divide both sides by 4. Guys, keep in mind, if you divide the left-hand side by 4, you have to divide each and every term by 4 on the right-hand side as well. Sometimes I see my students dividing this first term by 4 and they may forget to divide the second term by 4. Guys, we cannot do that. We have to follow the basic rules of mathematics. If you're dividing something to the left side, you have to divide everything on the right hand side by 4 as well. If there was a third term, you still have to divide that by 4 as well. Okay, so be careful with that point. So 4's cross out here, so it's simply y equals to, I can write this as 1/4 x plus 5. So I'm going to put that in the box, and if you look at this equation carefully, it is in the slope-intercept form. And we should be easily able to identify the slope because it's the exponent of x. Here the slope is 1/4. So I'm going to say the slope m1 is 1/4. M1, I used M1 for line 1. Let us call this line 1. Okay. Now let us take a note of that. M1 is 1/4. That is the slope of the given line. But we want to write an equation of a new line which is parallel to this line. But what do we know about the parallel line? The slopes are the same, right? So if M1 is 1/4, then what would be the slope of the new line? Let us call that M2. The slope of the new line would be the exact same, 1/4, right? So this 1/4. So I'm going to put that in the box because that's the piece of information that we are going to use. And then we also have the point. So the point is, it passes through the point 2, -3. Guys, from here, you already know how to actually write an equation because in the previous videos of writing equation of lines, probably it was type 2 or type 3, where we had I think it was type 3, we had a slope and we had the point, so you could just actually use those pieces of information to actually write the equation, correct? So let us go ahead and actually go through these steps again. The first step is to kind of identify or label this as x1, this as y1. And it would make sense here for us to use the point slope form rather than the slope-intercept form. Guys, if you are confident using the slope-intercept form, you can go ahead and use that. But here I'm going to show you using the point slope form, and we can always transform it back into the slope-intercept. So first I'm going to rewrite the the point slope form, which is y minus y1 equals to slope m, x minus x1, right? So let us go ahead and actually substitute the values. So y minus y1 is -3. I'm going to put that in parentheses. Slope is 1/4, and then I have x minus x1, which is 2. And simplifying this further, it would look like y plus 3, because two negatives are going to become positive. That's 1/4 x minus 2. Guys, at this point, we are basically done writing the equation of a line. But if you want to go ahead and transform it into a slope-intercept form, I mean, we already know how to do that. Let's go ahead and actually do it for this one. So in order to do that, you'll have to distribute this 1/4 carefully. So it's y plus 3 equals to 1/4 x. And 1/4 times -2 is going to be what? -1/2, because it's 2 and 4 is going to cross out. It's going to be 1/2. And then to get y by itself, you got to subtract 3 from both sides. And it's going to be y equals to 1/4 x minus, and if we combine these two, it's going to be -7/2. This here is my equation of a line which is parallel to this line and which goes through this point. And if, again, as I said, if you have a graphing paper, you can go ahead and actually plot that line, and you will see that they are parallel and they have the same slope, which you can already see from here. Guys, this has slope 1/4 and this has still slope 1/4, which is good because they are supposed to have same slopes. And if you look at the y-intercepts, the y-intercepts here is +5 and here is -7/2, so y-intercepts are different. So that's what you will see in the parallel lines. Slopes are the same and the y-intercepts are different. Guys, quickly, if you are wondering how did I get that -7/2, so I'm going to quickly show you how to actually simplify this. So I have -1/2 and -3. So what I'm going to do is there's an invisible one here. That's what I like to call the invisible one. So in order to combine these, we obviously have to have a same denominator. So how do we accomplish that? We multiply this by 2, multiply upstairs by 2, correct? So it is going to look like -1/2 minus 3 times 2 is 6/2, 2. 2 times 1 is 2. When you have the same denominator, we can combine the numerators. So -7 minus 6 is going to be -1 minus 6 is going to be -7. And then we have a 2 in the denominator. And that's how I got that -7 or 2, if you were wondering how did I get this. Okay, so I'm going to stop here for the parallel line. So I hope you got the idea how to write the equation of a parallel line, given a point. And then in the next video, we're going to talk about the perpendicular lines. Okay, thanks.